Hi everyone. Today I have a short video for you about a new approach to an existing problem in both Drupal core and the group module. It's a problem that many of us have faced before. It's a problem that many of us would like to see solved. And instead of trying to get it fixed in Drupal core, I try to fix it in the group module first because it's such a massive change in how we do things. So I figured let's try it out first, uh, commit it to one module, and then see whether we can get this system in core or whether people have different thoughts about this. So let's have a look. Um, so yeah, this is the intro. It's going to be a short video. I'm aiming for 15 minutes, hopefully, but we'll see where we land. So it is the video itself is about actually the handler system. And the handler system is something that we have for entity types, but also in the group module for the plugins that group uses to allow you to add other entities to groups. So the problem with this handler system is that whenever someone defines a handler, so for instance, a permission handler, a route provider, a storage handler, any type of handler, it is the module that defines the entity type that defines this handler. So if I am the node module and I have a custom node storage handler, then the node storage handler is part of the node module. And usually this handler extends one of the base handlers that Drupal core provides. So it uses inheritance. Now, let's say there's a module that wants to alter this for nodes. So what we get is we get this updated stack where they update the entity type info and they swap out the storage handler with their own. And logically, because they need to maintain the original functionality of the node module, they in turn extend the node module. So now you have this class that extends the node module storage handler, and it does some extra things. Now this is a problematic approach because it basically blocks any other module from doing the same thing. So if you have another module that wants to add stuff to the storage handler for all entity types, not just nodes, well, it can't. If you have a module that wants to add even more extra storage functionality, even though module A is already installed, it can't, because if B wants to inherit, it needs to know what to inherit from. So both A and B will probably specify the node storage handler as the class that they want to extend. So either way, through a race condition or a weight that they define, whichever module comes last is the one that gets the right to swap out that handler. But the other module is left in the cold and they don't have anything to work with anymore. It's just broken for them. So obviously this is problematic. This is just the way things go with inheritance. You never know who might inherit what, but the fact that we use these special strings to define the handlers makes it even more complex, because then, well, we're just swapping out one string for another and anyone can do that. And what I mean by these special strings is here. If you look in my PHP storm, we are looking at the definition of the node entity type. We define the classes inside of the annotation. So for storage, for instance, we say, well, you can find that class here. So if someone else was to swap that out and say, well, now you can find that class in my module, and my module makes sure that my storage handler extends node storage, that's all fine and dandy, but you just swapped out the one magical string in there, and no one else can do the same thing, because if they do so, the reference that you just inserted to your module storage handler is lost. So that's quite annoying to work with. Um, Group had the same problem. It used to define its handlers like that. And now it doesn't. Proof is here. So in the second version of the group module, which is currently under development, that whole logic is gone. So here's what I propose and what works really well for the group module. It's a handler system that works with decorators. And most of you might have already thought, well, the decorators, because Unlike inheritance, where you really need to know what you're extending, decorators allow you to, well, sort of extend anything at all. Like anything is possible as long as they support the same interface. So you can add your functionality to your heart's content, and anyone else can do that to infinity and beyond. It's just there are no limits almost. But the thing is, decorators don't lend themselves to that whole string approach that we just saw. And you would still have modules trying to fight over this magic string. So I did a little research and I found that Symfony, what we are using within Drupal, is actually very good with decorators. The whole Symfony container works really well with them. So I'll show you how I implemented this later on, but let me just quickly explain to you how I managed to tackle this problem, and then I'll show you a few pieces of code that actually demonstrate how well this works using Symfony. So let's go back to this initial stack, and let's go back to the scenario where we have a permission handler. So by default, you have a base permission handler that defines all of the standard permissions that any entity type should use if you were using core, or in the group module, any plugin should define. And I've split that up into two separate sort of stacks. You have your default handlers and you have your specific handlers. So the default handler is the one that always ships with the group module. If the group module says that there are a number of handlers, you have your permission handler, your access control handler, you have your post install handler, any of the handlers that the group module defines, the group module is responsible for shipping the default handler. And then you have your specific handlers, which any module that defines a plugin may choose to implement. And I specifically say may choose, because if you don't, then the group module will create that specific handler for you. And this is important because if people want to decorate your handler, then it needs to exist. So even if you don't define it, if the group module defines it for you, then people will, under the expected namespace, find a handler that is specific to your plugin. More on that namespace later on. So here we have your standard permissions and your member permissions, but you can choose to define them, and actually the group module has for the group membership plugin. And that in itself results in the standard permissions being handed over to the member permissions with a decorator pattern, so that the member permissions can add to or subtract from whatever is output from the standard permission handler. So it kind of looks like this in the final result. You have your standard permissions, those bubble up into the member permissions, and the member permissions is the one that gives you the final result. Very simple like this. Now, here's where it gets interesting. Suppose you have a module that says, I want to allow for translation support. I want to allow for domain support, where your permissions may vary based on the domain you're on. Then you would want that to work on any plugin, not just the group membership plugin, but also the group node plugin, the group media plugin, whatever plugin you're using, you want to make sure that all of these plugins have that support. So you add them to the default handler. And as you recall, the default handler gets fed into the member one. But the more you stack on top of that, all of this will get fed into the member one before the member one starts adding its specific stuff. And then you can still have modules that say, I don't want to add permissions to all plugins. I just want to add permissions to the membership plugin. And they can do that. They can add a decorator on top of there saying there is no join permission because I want to specify invite permissions. And then you can have one that says, well, out of the box, the group module doesn't have a permission that says you can edit roles. You just need the admin member permission. And I do want that permission, so I'm going to add it. That's all possible. And then the end result is that the top of the left stack gets fed into the bottom of the right stack, and the very end result is the top of the right stack. And that looks like this. So now you have your standard permissions, And just like any other plugin, you get your translation and domain permissions. And then because you're the group membership plugin, you still have your member permissions altered to have no join permission and altered to have an edit roles permission all in one go. And that is your permission handler. That is the eventual permission handler, this whole stack. So you start with just one and perhaps the second, and for free you get this functionality where you can have this entire tower of decorators doing whatever you want, and that will be the end result when you ask the plugin manager for the permission handler. So in comparison, just to reiterate, this is what it would look like if you put the membership plugin next to the nodes plugin. So they have the same shared base functionality because that came from the default stack. And then here they differ because here the membership plugin defines member permissions and the node plugin defines node permissions. But as you can see, this is where it stops, because the yellow and the orange decorator were only added to the membership plugin. So they don't affect nodes at all. And it's even possible for the nodes plugin to have its own decorator that is specific to just nodes. A decorator could, for instance, open up a UI where you can see the node grants. Even though I'm not a fan of node grants, it's a possibility. So let's continue with a quick demo of how that works in Symfony and what that might look like. Okay, so here we are in PHP Storm again, and we're going to look at how this whole system works. So I started off by saying that it's a specific feature in Symfony that we're going to be using heavily to make this whole thing work. So what that looks like is we are going to define our handlers as services rather than magic strings, and these services need to follow a specific naming pattern. That's how we get things working. And I mentioned that each module that defines a type of handler, so group obviously defines the most, but another module could do the same thing, that they need to define the default one. And the default one is under the namespace group, relation handler, and then the machine name of that type of handler. And you just define it as a service. And it's really important that you define it as a non-shared service, because as you recall from the slides, we have this whole stack that will be initiated at one point for a group membership plugin. But then the same bottom part of that stack, because those were the default handlers, could get initiated for the nodes plugin. And we don't want them to get mixed up about what plugin they're serving. So by making these services non-shared, we can make sure that whenever we request this service, we get a new instance so that we can feed it the right plugin ID and make sure that the next time this service is called, it doesn't still contain the plugin ID from a different plugin for which it was called. So it's really important that for this whole system to work, you need to work with non-shared services. So yeah, we have currently in development, we have the access control handler, we have the permission provider handler, and the post install handler. And as I mentioned, if you don't need to change anything, you don't need to define it. So as you can see for the group membership plugin, we have the next naming pattern, which is still group relation handler, name of the handler type, but then you add your plugin machine name to it. But we can see that it only defines the permission provider and the post install handler. It does not define the access control handler. And that's fine. If you don't, group will define one for you. So they too are shared, non-shared services, and they expect to receive the default one. So this is really important. When you in your module define a specific one, you request the default one. So here you can see that this matches this. And that's all you need to do. Now I'll get to the decorators in a second, but you can see a very basic decorator pattern here. The specific one gets the original one as its sole argument, but as you can see here, you can add more arguments to that, and it just works. So how do we get that whole stack working? Well, that's the cool part. And in order to demonstrate that, I need to go into the tests where I'm testing this behavior, and we have this alter plugin, and we look at the services file there. Let's close this. So you can see that in order to decorate something, you can decorate both the default handler or you can decorate a specific one, as I demonstrated in my slides. And here, for instance, we add a bar admin permission. It's tests, so it makes no sense, to all of the plugins. So what we do is we say we decorate the default one. So you can see that naming pattern again. This is the naming pattern for the default one. And we say we decorate that and we give it a decoration priority. And here, when you use this with Symfony, you need to just repeat your own service name and add inner to it. Now, in more recent versions of Symfony, I think starting from Drupal 9, we can use that syntax. You can just write @inner. But this version of the group module still supports Drupal 8 for the time being, and I don't know for sure if Drupal 9 supports this syntax, but you can do it like this also. It's just a little more ugly. One thing of note is that it doesn't matter what you name these decorators. Absolutely doesn't matter. Because no one will ever need to know how you name your decorators, because that's the cool thing. You are decorating this service right here. And someone else can decorate it, and someone else can decorate it, and someone else can decorate it. And they don't need to know how many people are decorating it, because once you ask the Symfony container for this service, it will go over all of the decorators, make sure that the decoration priority is respected, and then start building this tower of decorators where they all get the previous one injected. So the one with the highest priority gets the default one injected, the next one gets the one that just got the default injected, and so on and so on. So this is how we construct that tower. Now, obviously, you can do the same for the specific one. So this one still adds to all plugins with a heavier priority. But then here you can see that we add one to a specific test plugin called Node as Content. And you can see that we are decorating the Node as Content one. Group, relation handler, permission provider, Node as Content. And now you might start to realize why we define the services for you if you did not define them yourself. So in case you have nothing to add to the default, we still define a service for you because people need to be able to target your specific plugin. And for that to be possible, we need to define that service. So if you don't, we do. And we do that in the group service provider. Here we have a list of all of the possible handlers, and we have a class which is just empty, and I'll show that one in a second. Now, this is just a work in progress. I'm going to put that into a separate service that I can call here so that other people can call that service too to get that list. You never know why they might need them. You might want to extend that list, who knows. But either way, Group will add them for you. So it will just create that magical service name. So we're still using magical strings, but in a way that is easier to extend. This shouldn't block anyone from extending the group module's plugin handlers. And we just check the container, and if that service does not exist, we create that service for you, we set it to non-shared, and we feed it the default one. And that's all that is. So let's go have a look at so I can close this, this, and this, and let's go have a look at what these handlers look like. So before we get started, this is the structure of all of the group plugin related stuff, like the handlers, the plugins themselves. And the only one that really matters is this one for finding the actual plugins, but this is just a naming that I'm using for people to more easily find the classes. So the default ones are in here, but the empty ones, which you will get if you don't specify them yourselves, are in here, and they use traits. And this is the cool thing. So if you don't have a permission provider, you get this one. And you can see that it doesn't do anything. It receives a parent because we know it's a decorator, and it assigns that, but then it just uses this trait. More on that trait in a second. Access control handler, the same. Post install, all the same. So let's dive into one of these traits because that is where the magic happens. So you get all of this for free by the way. And if the group module decides to introduce a new method, you should be using the traits and you will automatically get that new method, as will all of the other handlers. So that's the cool part. So for a permission provider, for instance, we have the get admin permission, get permission, and build permission. Those are the three that you can see on the interface. That's all they need to do. And that is important again, because when you're using decorators, you want them to have a very concise interface. If it's too long, then the decorators get messy. So just have the handlers do one thing and have them do it well and not be bothered with anything else. So let's look at this trait. What does it say? If there is no parent and you're trying to call this, then we throw an exception. Because either you override it in the default one, or you just use it, but if you use it, it means you are one of the decorators somewhere down the chain, so we need to be able to call the parent. So that is what happens in here. It happens for all three of them. And then we have some helper functions that you can use to build your list of permissions, or in case of the access control, to do whatever. So it's just to prevent people from copy pasting the same code all the time. But that really doesn't matter because it's not part of the interface. It's just there to help you. So when we have the default one, obviously we're going to override all three of these trait methods, because otherwise we would get that exception. But you don't have to. And that is why when you have this empty provider, it suffices to just use the trait, because the trait will just call the parent and return that result for you. Easy as. If you need to override just one method, you override just one method. And I can show you an example of this in the group membership permission provider. It does not have a method for the admin permission, but it uses the trait. So it doesn't need to do anything. But it does want to change a few permissions. And this is basic decorator stuff you're seeing right here. Basically, it's saying if you want to create the membership or you want to delete anyone else's membership, we're not going to allow you to do that because that is handled by the admin permission. So there are a few exceptions here where we change the results, but otherwise we just return the parent. And that's good decorator behavior. You do your thing in your case, and otherwise you just delegate it to the parent. And that one can relegate it to the next parent and the next and the next and the next, all the way down the chain. Same for building the permissions. We just want to change some labels and we want to make sure that we use the new permission names. That's it. I could go over the default ones, but as you can see, it just needs to make sure that everything is implemented. It still uses a trait for those helpers, and just, you know, as for good measure, so that we all use the same trait. But here you can see that the default one obviously does not receive a parent because it is the first one down the line, and it should always be the first one down the line. So yeah, that's that system in the nutshell. So I have a few examples where these handlers are extended, but basically it's that simple. So if we go back to our tests and we look at the plugins here, you can see that you can have some very simple decorators that you can add to the handler stack. Basically, this one just says, you know, give me the admin permission, and I'm going to add the string bar. And then I'm going to add baz. And then I have a test checking whether we have the right decoration priority. Like, does it add bar baz or does it add baz bar? It's simple as. So yeah, I could go on and on and on about this. I'll just show the final piece to the puzzle, and that is the group relation type manager. Type manager, which is where we get the handlers. And this piece of code is where the magic happens, where, as you recall from the slides, let me try and go back real quick. So if I right click, yeah, okay. So where the bottom part gets injected into the top part, that's where this happens. So basically when we try to create a handler instance, we get the service name of the specific one. So in this case, that would be the group membership one. Obviously, we check whether that service exists, and it should, because we polyfill it for you if it doesn't. And then we get that service name. And because we request it, it will get decorated, and we will actually maybe not get our group membership one, but we will get the 17th decorator of that group membership one. And then we create that one, and by getting it, we automatically feed it the default one, because as you recall in the services file right here, I mentioned that it's really important that your specific ones ask for the default handler. So it will inject that one, and that one will also be decorated to its heart's content before it gets injected. So that happens automatically when we request that service. And then we call the init method, and we give it the plugin ID, and we give it, well, it's called a group relation type, but that's basically like an entity type. It's the plugin definition, but instead of an array of values, it's a class. And that's it. And if we go to that init method, you can see that the relation handler interface just has one method, which is init, and that gets called for all of the ones in the relation handler trait. And that just makes sure that all of the handlers know what plugin definition they're working with and what plugin ID they're working with. And again, if there is a parent, it will make sure that init is called all the way down the line. That's it. If this video intrigued you, if you enjoyed this, if this is the type of complex solutions that you really love seeing, you might want to consider joining our team. We have plenty of developers here like me who are capable of coming up with these solutions, sharing these solutions with the community. So if that is the type of environment you want to work with, definitely visit factorial.io/en/jobs and have a gander. We're still hiring various types of people right now. We have our very pretty Hamburg office. It's really in the heart of the city. But if you're not German or not from around Hamburg, that's not a problem. I'm from Belgium. We have a team from all around the world. So wherever you are, if you want to join us, we are still looking for talented people. So thank you for listening. You can contact me directly at this email address if you have any more questions. I'm also available on Drupal.org under my full name, Kristiaan van den Einde. If you look up the group module page, you will find me there as the author with a link to my profile. And from there, you won't have a link to my Twitter profile. You can also find me under the same name on Drupal Slack. I'm generally pretty reachable through these channels. So yeah, definitely show some love, provide some feedback, and hopefully until next time.